the drinking water treatment plant in a Nawabshah city. So this design is made by Anjum Khanj. So as you all know that one of the most important substance in the earth to sustain the life is the water. So it is a very important that it should be clean and safe. So here is the overall contents which I will cover in my this presentation. So this is the plant site for a water treatment plant, and here is the Gajrawa canal, which is the water treatment source, and the area for a water treatment plant site is a 0.5 square kilometer, and the longitude for the plant site is a 68 degree 22 minute 51.22 seconds, whereas the latitude is a 26 degree 18 minute 2.15 seconds, and this plant's location is designed by Google Earth software. Now, which is the water source and the quality of that source? Now we will discuss about that. So the water source, which is the mostly used by the people of Nawabshah for drinking purpose, is the Gajrawa Canal. So it is located at the center of Nawabshah city, as it possesses high pH 8.4 and a high turbidity value 714 FTU. So it is not fit to consume directly for a drinking purpose. So now the population and design period of a water treatment plant. Population can be estimated by population forecasting method. In 2025, the population of a Nawabshah city will be 4,88,781, whereas the population in 2045 will be 6,98,345. So the construction period is a 4 years, whereas the operation period of a plant is a 20 years. Now, the water consumption can be categorized as the domestic water consumption, which is a 131 liters per capita per day, whereas a non-domestic water consumption is a 120 liters per capita per day. So, non-domestic consumption can categorize as the industrial, irrigation, and the losses and the leakage. Whereas the domestic water consumption mostly consumed for a bathing purpose, secondary for laundry purpose, third for a drinking purpose. Now, the demand of water for present population, the demand of water is 1,22,684 meter cube per day, whereas the future population demand of water is 1,75,284 meter cube per day. Now, the daily flow rate for present population is 2,20,831 meter cube per day. Daily flow rate for future population is a 3,15,512 meter cube per day. So now the clean drinking water train. So the surface water treatment train in the preferred design is the conventional water treatment train. So in this the canal water goes to reservoir, then screening section, then coagulation, after that the flocculation, after that sedimentation, then filtration, after that the disinfection, and then goes to the storage tank for a distribution purpose. So first of all, reservoir. Reservoir is a storage space where fluid can be stored for a rainy purpose and other purpose. And in this design, we prefer the circular reservoir because it has a strong geometrical structure and it can minimize the surface area and which can radiate the heat. They keep the enclosed water at a more constant temperature. So the reservoir capacity is a 3,15,512 meter cube per day, and the area of the reservoir is a 6,31,002. Now the pipe design for this water treatment plant are two pipes are considered. First one is a reservoir to treatment plant pipe. So the dia of pipe is 7 and the area is 39 meter square and the velocity is 0.4 meter per second. So the second pipe is the canal to reservoir pipe. So its dia is 3.3, area is 8.5 meter and velocity is 1.9 meter per second. So the pump design for this water treatment plant, two pumps are considered. Centrifugal pumps are considered. First pump BHP is 32.36 and second pump BHP is a 16.18. Now the coagulation. In the coagulation process, particles are destabilized and the coagulant is added to raw water. And the coagulant which we preferred in our design is alum. Why we choose alum? Because it is an inexpensive, widely available and easy to use. And the dia of a coagulant tank it can be calculated as 1.32 and the rotation speed of ampuller is 100 rpm and alum dose is a 20 milligram per liter. Now the flocculation, in the flocculation large floc particles are generated and a mechanical rapid mix unit of a radial impeller is chosen and four flocculation basin and compartments are chosen. So the volume of a single compartment is a 273 meter cube and the tip speed of impeller is 13.4 rpm. Whereas the length of a compartment is 8.8 meter and dia is 9.9. Now in the sedimentation process depend upon the size and the shape of particle. Round particle are easily settled as compared to irregular shaped particles. So the sedimentation tank length is a 194 meter and the detention time for sedimentation tank is a 5 hours and the area of tank is a 9390. Whereas the surface loading rate is a 1400 liters per day per meter. Now the filtration rapid sand filters are chosen in the preferred design because they require low space and they have high flow rates and there are a cost effective method of treating contaminated water. And number of filters calculated is 11 filters and the area of filter is 79.6 and filtration rate is a 330 and the media is chosen as anthracite coal, sand and gravel and the length of a filter is a 9 meter whereas the dia is 4.5. So the disinfection is in a proposed design. Chlorine is used as a disinfectant because it is a cheap and readily available and disinfection tank length is a 57 meter whereas the velocity is 0.03 meter per second. Now the clean water reservoir is similar to feed water reservoir because it is used for storage and it can transfer water to the distribution. Now this is the overall layout of a water treatment plant in which the surface water treatment train component are present. Now this is the layout which we have concluded by using WattPro software. And here is the overall summary from the WattPro software that the flow rate from effluent 01 to 06 is the 3,15,512 meter cube per day, whereas the pH at effluent 01 you can note that is a 8, but at the last the pH reduced to 7.8. Now this is the overall result which we concluded that disinfectant usage is a 0.14 milligram per liter and then the turbidity value is 0.5 but we have achieved 0.3.